Well, welcome. This is actually my first attempt to actually make a video related to one of my Retrodesmos activities. And it could be the last. We'll see how this goes. I don't know. But kind of the vision behind this is I had the opportunity to work with some teachers and show them some of the activities that I had and really the power behind Desmos and how it can be used to actually transform your classroom a little bit. And I really just kind of wanted to share that message out there. And if you enjoy these, I'll be happy to make more of them. Or this, like I said, it could be a one-time trial here. But before I actually dive into this lesson, let's just take a second, and I just want to share a little bit of my thinking behind this. You know, we have taken some of these old video games, me and Mr. John Rowe, and we've created some of these Retrodesmos activities, and the power is really obviously in the engagement piece. You're drawing kids in. Students love video games. They watch other people play video games online. It's something that they're invested in, and we should be bringing those things into our classroom regardless of what they are. But the other thing is video games kind of allow me to create situations where I can pull out some mathematical ideas for students. They really set the stage for a lot of different things to go on because I can manipulate characters, I can manipulate scenarios, and really allow students to experience something and then relate it to mathematics. And I don't know if we necessarily do enough of that in our classrooms. And so that's just a little bit of my thinking behind it. I know John might have a little bit of a different take on it, but that's really what I'm after, is really just trying to reimagine mathematics and really try to draw in on student interest and get them to understand or see mathematics and the beauty behind mathematics in a little bit different way. So the activity that we're going to do today is Mega Man Modeling. It's one that I built. It was kind of earlier on, but there's a lot of good stuff that's going on in here, and I really just wanted to talk about it, show you kind of the reasoning behind it and the purpose behind it. There's some subtle things that maybe if I didn't talk about them, you wouldn't see if you were actually using this as a lesson in your classroom. And I'll kind of share where I think there's some good points for discussion, maybe some things to build upon, and some ways to actually implement in your classroom. And like I said, if this video, if you enjoy it, I'll be happy to make more. But without rambling on too much more, let's go ahead and kind of dive into the activity a little bit. So if you don't know, Mega Man was a video game that was pretty popular in the late 80s, early 90s. They're still making them now. They're still, I believe, making new ones now. But that was kind of the height of where it was at. And Mega Man's this robot, and he's going around, and he's after some other robots to actually defeat them. And we'll actually, as part of the game, we'll actually defeat a few robots, kind of a goal for students as they go through the activity. But really, what I like about it is there's a lot of different power-ups, and we can use them to represent a few different things. And so let's go ahead and go into the activity. And so I'm going to push go here. And it's going to bring up this first screen, and it's kind of a little bit of a tutorial for students. And if you'll notice, there's some objects and some items there. The first one is this energy tank. In the Mega Man game, the energy tank actually kind of adds health back to the character, and it could be a variable amount depending on how much health your character actually has left. And so kind of that's going to be our variable for this activity. The purpose and the underlying goal of this is to actually show students how to model equations in order for them to be able to solve them. And I really believe this is important because we as teachers are often guilty of jumping straight to algebraic language first before we actually develop any concepts with students. And I think that kind of limits some of the access to some of the curriculum for students, because if they don't understand the algebraic language or that they don't have an understanding of algebraic rules, they're going to be left behind. And I like I said, I feel like we do a disservice when we do that with teachers. Obviously, they need to know algebraic language. It is the language that we use and that we share mathematics with. But if I was to go and try to learn a foreign language and I didn't have any idea of a concept and I was just trying to learn it in this other language, it's going to be difficult for me. And I think that is kind of some of the struggle our students go through. So kind of getting back here to the activity, we've got those energy tanks, and they're going to represent our variable. The goal of each one of these activities or each one of these stages that we'll run into in the game is we're trying to figure out how many of either these yellow or red circles are actually inside each energy tank. These values are a little bit more stable. They give a little more consistent of health back. The red one I actually made up. There's not any red ones in the game, but to me, if you have those red and yellow counters, this really parallels with that really well in your classroom. I've actually, when I've taught this lesson before, I shared this lesson with teachers, I printed out some pictures of some E-tanks and got out the red and yellow counters, and we actually built out models as we're going through the solving process. Now, the purpose of this first screen is to introduce these symbols, obviously, but also down here at the very bottom is this notion of kind of the additive inverse of getting a positive 1 yellow and a negative 1 red, and if we put them together, it gives them the value of 0. And that's really what this question is asking here. And I really don't care that much about the answer. What I want to see from students is what their thinking is behind it. Do they understand that when we combine those two things, we're really creating this additive inverse that we're going to have to use as a tool as we go through and actually solve problems? And if they don't, I mean, I would probably stop right there, have some discussion, talk about what it means, and physically show them with red and yellow counters how they actually, you put one against the other and it zeroes each other out. And so once they have that notion, we're going to dive in a little bit here and we'll look at this first stage. Now, in each one of these activities or each one of these screens at the very top, you'll see kind of these black rectangles up here at the very top, and you'll have an equal sign right there in the middle. This kind of sets up the area for where the actual models are kind of being built, and eventually we'll get to some actual problems in algebraic language up there towards the end of the lesson. So if you notice, we've got an energy tank here, we've got a yellow circle here, and then we've got 3 other ones over here. So really, this is merely the equation x plus 1 equals 3. And so kind of our goal is to be able to solve this equation. And if I just go ahead and push the Go Mega Man button here, you'll notice with the kind of the power of Desmos, I'm able to animate the actual model of solving. And if we go back and we think about our 0 pair that we had before, these two values actually zero each other out. And we can see that the energy tank, or a variable for instance, is worth a value of 2. And so I can go ahead and put in the value of 2 here. And now that I have the correct value, notice Mega Man actually clears the screen and actually provides some feedback for students. Again, one of the beauties of Desmos, one of the powers that you have there is to provide that feedback for students so they understand, okay, I'm on the right track, or maybe I need to pause for a second and get a little assistance before I move forward. So let's go ahead and let's move on to that next screen. And so notice I've upped the challenge just a little bit here. I've got 2 energy tanks over here and 1 yellow. And on this side now we have 3 again. Didn't really change anything over here, just really added the idea we have that second variable. And so if I push Go Mega Man, again, it's going to show them the model. And it's going to add this little extra piece of actually pairing each one of these inside of the energy tank. I think students might think this answer is the same as the previous one, but in actuality, we can see the one goes in each one of these with the model. And now I know in these early stages, I model the problems for them. I show how it actually works. Eventually, we're going to take that away. We're going to kind of push that onto the students and see what their understanding actually is. But after doing the model, hopefully we can realize that the value there is 1. And again, once we get that right answer, we get that feedback. We get to see Mega Man clearing the stage there, and we're moving on. And so now we enter our first boss encounter, and usually I think this is the only one that I actually still model the equation for them as far as the boss battles. But here we've got a little bit trickier situation. So we added some more values over here. We added an extra one over here. And I think if I push Go Mega Man, we can kind of see the model going on. And oh man, already throwing an interesting question. Probably this is something I would take a moment and pause and ask students a little bit about. What's actually going on over here? We're left with 2 energy tanks, and we're left with 3 of our little yellow counters here. And hopefully that would prompt some good discussion. I think we're too resonant sometimes to jump to decimals early on. I think it provides some great context, and I'd love to have a debate with a student about what should happen with this one here in the middle. Do we actually split it up? What are we supposed to be doing with it? Great opportunity for discourse with the lesson, but let's hit the reset button here and let's go ahead and put in the right answer of 1.5 again, and we'll see Mega Man kind of defeat that first boss. and we get to move on. And so again, kind of, I hadn't talked about this, but the way this lesson's kind of set up is we have a couple sample problems that kind of build to a boss battle, and then we move on to kind of a new set that introduce more of a different twist on the actual equation solving. You know, I'm really big on problem strings and just kind of adding slow pieces as we go through. And I think that's a great way to develop some conceptual understanding for students. And so here we go. We move on to this second stage and notice a couple things here. Obviously, there's a bunch more, but I kind of threw the variables from the left side of the equation to the right side. We really need to develop this idea of equivalence, that really it's not just leading us to an answer, it's really a balancing between two quantities that we have going on here. And so again, I can kind of use what I know about additive inverses or zero pairs and get this guy and this guy, zero those two out, because what I do to one side, of course, I have to do the other. And so that's going to leave me with, looks like groups of 4. Again, I could test it to get a little feel because we're still early on, but we can see that the value of each energy tank here, or each variable, is going to end up being 4. So again, that little twist of kind of moving the variables to the different side on students. So again, have the variables over here as we move to this next stage. We've got 8, or is that 10? We've got 10 there, and we've got 1 over here. So it looks like we're going to encounter a decimal again. I can go ahead and I can realize I can move this one, I can move this one. That's going to leave me, I'm going to go ahead and push the model, kind of get an idea here. Again, opportunity probably for some good discussion about this extra one kind of hanging out here. What does that actually mean? And so it looks like we've got 4.5 going on. So I'm going to put that in. I'm going to get some feedback. Again, another reason I love using video games or using these in activities is we have a goal. We're trying to get Mega Man to the end of this level, trying to get him to advance on. And so here we have our second boss battle. And you know what? I'm going to go ahead and just push Go Mega Man. And notice I didn't model it for him. So we've had 4 or 5 examples now. We've kind of built our way up and slowly removing those supports and kind of pushing students out on their own. And so let's see what we actually have going on. We have this extra one hanging out here. I can use a zero pair and get rid of this guy. And so I've got 1, 2, 3, 4, 5, and it looks like it's going to leave me with 10. So that's 1 pair, 2 pairs, 3 pairs, 4 pairs, 5 pairs. So that's going to match up, and that's going to give me 2 in each one. And again, you know, if a student is struggling with this, I would stop, I would build it out, I would have them physically take counters or whatever you want to use and have them match them up and place them on top of energy tanks. If I have an opportunity in this video, I'll put in a picture of what I mean from when I use this with actual teachers over the summer, or, you know, I've had some people on Twitter use this activity and send me pictures of all the different ways students are trying to solve this problem. You know, I think there's great opportunity to show multiple representations for students. And so let's get past this next boss here. Again, I love the ability to animate and see that feedback. And I've had students really anticipate what's going to happen. They're always worried if Mega Man's actually going to clear that stage or not. And so we moved on. We've gone through our first set, our second set, and now we've progressed to our third set. And if you'll notice, here's kind of the added piece. We actually have some negative ones out here. So again, I love this visual right here because there's really we don't have that negative symbol kind of clouding things up and confusing some students with subtraction and everything going on. We have the idea that these two different colored counters pair each other off and give us 0. And so let's see what we do here. We need to get all of these guys over here. So I'm going to have to cover all these up with yellow. So really, I'm not losing this guy. I'm just bringing over 1, 2, 3, 4, 5 more over here. And I've got my 2. So I believe that's going to end me with 3. And since I've introduced a new concept, I've given them some model support too here. I didn't pair it up though. I just gave them the initial kind of new part to show them what actually happens when you zero out with the red. I didn't actually bring 3 over to show them the pairing like I've done previously. And let's move on to this next one. Again, now we have, we had negative and positives on this one. Now we've got, looks like I've set up negatives and negatives, so a little different twist, not too much different, but the same idea. We're going to cover these up with yellow, but we're going to have to do it with this guy too. And so that's going to kind of end up leaving me with 3 over here, and then I can partner those up with each one. And again, lots of different ways to actually talk about the process of going through and figuring these out with your students, but looks like we're going to end up with 1 for each one of these. And again, don't have that pairing support, really just kind of showing them again, it doesn't really matter if it's positive or negative. It's more about, do you understand what it means to follow this pattern or take apart this pattern and create a situation where you can figure out the mystery of what's inside of each one of these energy tanks. And we're moving on to our third boss, and again, it's a boss battle. I don't model it for them. They need some support. They can always go back and look at these previous 2 examples, but let's reset it and see what we've got. We've got 1, 2, 3, 4. These 2 guys I need to cover up with yellow. So I'm going to bring some yellow over here and actually threw a little bit of a wrinkle at them too, because when I do that, I'm going to be left with just these 2 or just 2 of the red counters over here. So that means I'm actually now putting a red one in each one. Might be an opportunity for discussion here. Can you really put a negative value inside of a variable? What does that actually mean? Might bring up some interesting thoughts from your students. Might be a great time to pause and see what's going on. Again, Desmos allows you to facilitate this lesson in a lot of different ways, and I really encourage you to kind of do exactly what we're talking here. Go through a few screens, pause, check on your students, maybe stop and have discussion, especially if you hear some great discourse going on in your classroom. And so here we go. Looks like we're going to end up with -1 for each one of these. And we'll find out. Let's see if Mega Man defeats Bubble Man here. And he does. All right, moving on. Stage 4. Okay, so here we go. What's happening now? We've gone through those previous examples. I haven't shown them really any numbers, any letters, any variables. I really wanted to establish kind of a conceptual understanding of the patterns that we had going on here as far as with solving equations. And you notice now I've actually brought in the algebraic language. I think once we've established kind of the concept that we're going on, it's so much easier to now bring in numbers and variables and letters and have a sense of what they're actually representing. They're representing that action or that movement of moving variables, zeroing things out, putting things in groups. There's so many going on with 3x plus 2 equals -7 without a model or without some type of visual understanding. I don't know if students are going to really get the concept or not. And so here we go. Let's look at this. First thing I need to do is I'm going to go ahead and just push Go Mega Man. We'll see. Again, I'm going to give them some support. That's the first time they've seen it, and I actually really try to show them how these group up into 3 groups here. But you notice at the top too, I kind of altered the algebraic language a little bit for them as well. And so if we reset it, we notice that 2 of these guys appear over here as red when we zero out, and we're left with 3x equals -9. So I'm going to put these in 3 groups, which is what the yellow represented. And so I'm going to end up with -3 here for each one of these. And Mega Man's going to cross that stage for me. So moving on. Okay, so we had a little wrinkle here, a couple of them actually. In the previous problem, well, I guess I did have positive and negatives, but you notice here I love switching the order up on students. I think we're real bad about always putting that variable first. And there's nothing wrong with having this order here. It's a perfectly fine expression. But having it shown in a different way, I think, can enhance what their actual understanding of students is. And so we've got these negative or these red over here, 5. And so we're going to end up moving them over. And that's going to give me 16 when I put it with the 11 that I've got over here. And so I'm going to divide that into 4 groups. And so I believe I'm going to end up with 4. And I still think I've got a little bit of the modeling going on for them. Yeah, just the counterpart to kind of get them to see what's happening. And Mega Man defeated our guy, and we're going to move on. And now we get our boss fight. No support. Have I learned what it actually means with negatives in this algebraic language? And so we've got these yellows. We've got our reds. We're going to move these over. And you know what? I'm going to end up with a decimal, which is good. I like throwing that little wrinkle at them, too. It really kind of shows me if they've got that understanding or not. And if I push Go Mega Man here, I think we're going to defeat this boss. And there we go. Okay, so that was kind of taking us to level 4. We're already at the end. We're progressing to the final boss battle. And I want to show you what's happened now. So we've gone all the way from, x plus 1 equals 3. And to now we've got modeling. We've got some numbers going on. I really believe if students are able to switch back and forth between the model and the number or the numeric representation, they really have an understanding, because not only do they know what's going on, but they're able to visualize it in multiple ways. And I think that's so powerful for students. We've got to be doing more multiple representations for kids. And so here we go. We've got 19 over here. And you know what? If they need to, get out 19 counters and lay them all out. If they're still struggling with what this actually represents, or get out some whiteboards, have them write out 3x and these over here. I don't really care at this point. I've showed it to them multiple ways. And if they're able to process through it one way or the other, I think it's great. I think we've made some transitions with them. And then, like I said before, if they're able to go back and forth, I think they've really cemented what we're trying to get after in this lesson. And so we've got 1, 2, 3, 4 that are going to end up being red, which means I'm going to end up taking them away from here. And so that's going to leave me with 15. And then I've got 3 groups of 15. So that's going to end up giving me 5. If I did it right, hopefully we'll get a shot at this dragon here. And we do. All right. Move on. So now we went about it the other way. So before, I just gave him the number and modeled the variable over here with some extra yellow counters. And then over here now, we have the variable representation with algebraic language. And then we have our counters. And so that's -3. So that's 3 reds. I'm visualizing my model here. I got 3 reds. I'm going to make them yellow, which means these are going to transform into yellow over here. So 1, 2, 3, 4, 5, and then 3 more is 8. And I want 4 groups out of that 8. So I'm going to put 2 in each energy tank, I believe. Oh, let's see if he gets through there. Got a couple shots at him. All right, and here we go. We've made it to the end. And notice I've stripped away the model completely. We've gone all the way from that beginning, real simple model to, kind of our standard equation that we hope students are able to solve. And, to me, again, power of Desmos, using the video games to actually give some action and some meaning is so much more powerful than just a worksheet with a bunch of problems on it. And so we've got -4. I'm going to add that 4 over. That's going to give me -21. And so I believe I can take down this final guy with -3. And there we go. We defeated our dragon. And get a little bit of a celebration going on here. We are now a Mega Man equations master. Again, the purpose of this video was just kind of show you a little bit of the vision I had behind this. And obviously, after working through this activity, I would follow it up with more problems. Again, continue to give the freedom for students to look at different models in different ways. They can look at equations with the visual representations of the algebraic language. I think when you do that, you really enhance their learning and their experience for them. So I hope you enjoyed this. I'll be happy to make more of them. If not, I appreciate you making it all the way to the end. I've actually made 2 follow-ups to this one. I have one that actually has fractional exponents in the Mega Man 2, and then part 3 actually has variables on both sides and negative variables as well. I introduced that concept too. So again, thank you, and you can find all these activities at retrodesmos.com.